Alright guys, in this video we're going to focus on a little bit more of the math dealing with solutions. So one thing that we look at with solutions is the concentration of those solutions. So looking at the measure of how much solute is actually dissolved in that given quantity of solvent. So we look at how much of the salt or mineral is actually within that container. And we consider solutions to either be dilute or concentrated. So dilute solutions contain a small amount of the solute. So we generally say that it's less than 1 mole per liter is going to be considered dilute. And this will be different depending on what type of substance we're dealing with. Whereas we say concentrated solutions, these tend to contain 1 mole or more per liter in terms of solute. So dilute solutions do not have a lot dissolved in them. Concentrated solutions have a lot dissolved in them. Whenever we're actually finding the concentration, we actually calculate the molarity. This is what we look at to determine if it's concentrated or dilute. So molarity, which is a capital M, is the number of moles of solute dissolved in 1 liter of solution. So this formula is on your reference sheet. You have molarity equals moles of solute over liters of solution. So it's going to be moles over liters. And liters is the amount of the entire solution, not just the solvent. So this is going to be the total volume even after you've put the salt in it to be dissolved. So if you have 250 milliliters of water and then added solute to it, you would want to measure that final volume after the solute's been added. Molarities we tend to see on our solution bottles in lab. So you may have seen solution bottles with 1 m or 0.5 m, things like that. So this would be read as a 1 molar solution. So this tells us that there's 1 mole per liter of solution. Let's look at some problems dealing with molarity. So here we have an IV saline solution often administered to patients in the hospital. One saline solution contains 0.90 grams of sodium chloride and exactly 100 milliliters of solution. What's the molarity of the solution? And I'm going to write our formula. Remember, molarity is equal to moles over liters. Now, this is actually one of the trickiest types of these problems because it's looking for molarity. It did not give us moles. It instead gave us grams. So you have to use your knowledge from the mole unit to change from grams into mole. So we can go ahead and do that first. So remember, we start with grams. That will need to go on the bottom of our next step to change into mole. And remember, grams is always out of 1 mole. For our molar mass, sodium is 22.99 plus chlorine is 35.45. So that's a molar mass of 58.44 grams per mole. So we end up dividing those to solve for moles. So we have 0.015 moles. So that can get plugged into our molarity equation. And we also need liters, but it gave us milliliters. So we need to make sure to move the decimal. So remember, milliliters to liters, we move the decimal 3 times to the left. So this will end up being 0.100 liters. And when we divide those, we will now have our molarity, which is going to be 0.15. And our unit for molarity is just the capital M to show that it's a 0.15 molar solution. And that's all you're doing solving molarity. You may come across other problems that want you to solve for moles or solve for liters, but it's all using the same process. And like I said, this one gave us grams and milliliters, so these tend to be the hardest problems to encounter. Let's look at some more. Oops, excuse me, it skipped a slide. No, it didn't. Here we have a solution with a volume of 2 liters that contains 36 grams of glucose. If the molar mass of glucose is 180 grams per mole, what is the molarity of the solution? So, in terms of molarity, it doesn't give us moles, so we do have to convert that. But it did tell us that we have a volume of 2 liters. So we just need to change from grams to moles before plugging in. So we have 36 grams of glucose. It tells us the molar mass of glucose is 180 grams in 1 mole. So if we do 36 divided by 180, we get that it's 0.2 moles. And I'll give it the 3 sig figs like we originally have. So if we do the 0.2 divided by 2, we get that this is a 0.10 molar solution. Like I said, we can also use this to solve for different variables. So here we can actually solve for moles instead of molarity. So we have household laundry bleach is a dilute solution of sodium hypochlorite. How many moles of solute are present in 1.5 liters of a 0.7 molar sodium hypochlorite solution? So you want to plug in what you know. It tells us our molarity is 0.70 molar. We're looking for moles. And it tells us we have a 1.5 liter solution. So if we rearrange to solve for moles, we're going to end up multiplying by the 1.5 liters. So we're going to have 1.05 moles. And in terms of sig figs, everything else had 2 sig figs, so we can actually round this to 1.1 moles as our final answer. It could also ask you here to solve for grams. So once you find moles, it may have you convert to grams. It may also bring up problems that ask you to solve for liters, which you would just simply keep rearranging the equation to solve for liters. Right? With solutions, we can also undergo dilutions. So diluting a solution reduces the number of moles of solute per unit volume, but the total number of moles of solute in solution does not change. So we're simply adjusting the volume to either increase or decrease the molarity. So we can calculate how much we should dilute a solution to get a new molarity. So the formula given on our reference sheet for dilutions is this M1 times V1. So your beginning molarity times beginning volume is equal to M2 times V2. So your final molarity times final volume. Because the number of moles stays the same, they simply rearrange the molarity formula to solve for moles, and that's where we get these factors. This a lot of times we'll use whenever we're prepping for labs. Whenever we order chemicals, for example, hydrochloric acid, it is going to come as 6 molar hydrochloric acid. That's too strong for me to give a student. So I have to dilute it and actually decrease its molarity before I can safely give it to a student to use. So you might end up only using a 1 molar hydrochloric acid solution or a 0.5 molar hydrochloric acid solution once I'm done going through the dilution. Let's look at how these are going to appear. Here we want to know how many milliliters of aqueous 2 molar magnesium sulfate solution must be diluted with water to prepare 100 milliliters of aqueous 0.4 molar magnesium sulfate. So the hardest part here is making sure that you put the correct numbers on the same side together. It doesn't matter which pair you put as your beginning or final molarity and volume, as long as you pair them together correctly. So note it wants to know milliliters of a 2 molar solution, so those need to be paired together on one side. So our formula was MV equals MV. So we have a 2 molar solution of an unknown volume. And you can leave the volume as milliliters as long as it is milliliters on both sides of the equation here. Whereas with molarity, you had to plug in liters. So we're diluting it with water to prepare 100 milliliters of a 0.4 molar solution. So once you've kind of paired everything together and plugged it in, you simply have to solve for that missing volume. So 0.4 times 100, I left the volume in milliliters. We are going to end up dividing by 2, and this will end up being 20 milliliters. And note everything, or the smallest number of sig figs up above was 3. So we're going to have 20.0 milliliters as our final answer. So that's how much of the stock solution I would put in to a volumetric flask and then just add water until it reached the 100 mark. I believe I have one more of these. I double check. I think that's my last one. Yeah. So last problem, how many milliliters of a solution of 4 molar potassium iodide is needed to prepare 250 milliliters of a 0.760 molar potassium iodide solution? So yet again, beware of how you pair these together, but it doesn't matter which information you put on which side. So we want to know milliliters of a 4 molar solution, so those should be paired up on the same side. Needed to prepare 250 milliliters of a 0.760 molar solution, so those will be paired up on the other side together. And we're going to solve for that unknown volume. So 0.760 times 250 divided by 4, and our answer should have 3 sig figs. Is going to be 47.5. And remember, our volume we left in milliliters. So that would be my final answer. Go through and complete the practice problems using the molarity and dilution formulas.